Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 7th graders out there, though all children are welcome to tune in. This lesson is the 5th in our series. My name is Kayla Anderson, and I'm an 8th grade teacher in Tennessee schools. I'm so excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see our previous lesson, you can find it on the Tennessee Department of Education website, www.tn.gov/education. You can still tune into today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Today we will be creating inequalities to solve real-world problems in mathematics. Before we get started, to participate fully in today's lesson, you will need paper, pencil, and a surface to write on. Okay, let's begin. Today our focus will be solving inequality word problems when presented in a real-world scenario. Inequalities are similar to equations, just with a little twist. What are the differences and similarities between an equation and an inequality? Remember, equations show equality and use an equal sign. Inequalities represent quantities that are greater than or less than a given quantity. So I'm going to put some vocabulary words on the board along with some definitions and some symbols. It may be a good idea for you to write these down so that you have them to refer back to as the lesson progresses. They won't be here the entire time, so if you'd like to write them down, I'll pause so that you can do that. So since we're working with inequalities versus equations today, we want to go back and review some of those things a little bit. So keep in mind that an equation has an equal sign and it shows equality. An inequality does not have an equal sign, and it doesn't show that two things are equal. So for inequalities, we use symbols such as the less than symbol, the greater than symbol, the less than or equal to symbol, and the greater than or equal to. So I'll pause for just a second so that if you'd like to write any of that down to refer back to later on, you can do that. Okay, let's keep going. So also recall that when you're solving inequalities, it's really similar to when you solve an equation, except that if you multiply or divide by a negative number, you have to reverse that inequality sign around. So same procedures for isolating that variable, but instead of just normal equation happenings, when you multiply or divide by a negative number, you do have to reverse that inequality around. All right, so let's go ahead and put this into practice and look at our first problem. The annual county carnival is being held this summer and it will last 5.5 days. Use this information and the other given information to answer each problem. You are the owner of the biggest and newest roller coaster called the Gentle Giant. The roller coaster costs $6 to ride. The operator of the ride must pay $200 per day for the ride rental and $65 per day for a safety inspection. If you want to make a profit of at least $1,000 each day, what is the minimum number of people that must ride the roller coaster? Your job is to write an inequality that can be used to find the minimum number of people, which we'll represent with P, which must ride the roller coaster each day to make a daily profit. Okay, so we've got the question here, and keep in mind that we are using the variable P here, and it's going to represent the minimum number of people that need to ride that ride. We're going to start by picking out the important information, and I'm going to highlight it here. You may want to jot it down on your paper. So it costs everyone who rides the ride $6. So that's going to end up being important. So it costs $6 to ride the roller coaster. Okay? Now let's talk about the expenses that are involved in order to keep that roller coaster running. So how much does it cost to rent the roller coaster? Right, $200 per day. So $200 is going to be the cost, that's per day, to rent. Okay. How about the cost for the safety inspection? Yep, that one's $65 per day. So $65 per day for the safety inspection. Okay, let's keep going. The other information that would be helpful here is, what was the profit that you want to make every day? You want to make at least $1,000. Now, it is important that we keep in mind and that we pay attention to and highlight and write down the fact that it's at least $1,000 every day. So we want to make $1,000 or more as our daily profit. Okay, so now that we have the important information, we've found it, we've figured it out, what we're going to do is set up an inequality in order to solve and answer this question. So if it costs each person that rides the ride $6, then we're somehow going to use that $6 in conjunction with our variable P to solve this inequality and start setting it up. So as I clean the board up a little bit and get ready to write down our inequality, think about how will you use this information that we've written down as the important information to write your inequality. Okay, so now that you've had a chance to think about it, keep in mind that we're paying every person is paying $6 to ride the ride. So that 6P is going to be part of our inequality. The other thing that we have to think about is, what daily expenses does the operator have, and what would we do with those daily expenses? Are we going to add them to the 6P, or are we going to subtract them from the 6P? Right, we're going to subtract them because they're daily expenses. We're going to take away the daily expenses from our 6P. So the first daily expense was the $200 per day. So we're going to be subtracting 200. And then we also have to subtract the other daily expense of 65. So 6P minus 200 minus 65. Now we can go ahead and simplify that and clean it up a little bit. We don't need minus 200 and minus 65. So by combining like terms and simplifying things here, we know that we have 6P, which is $6 for every person that rides the ride, but we have to subtract those daily expenses of $265. Okay, now what we have to figure out is, what kind of inequality symbol do we need? We know that we want to make a profit of at least $1,000. So do we need a greater than or equal to or a less than or equal to sign if we want to make a profit of at least $1,000? Right, we need greater than or equal to. So this profit that we're making here has to be greater than or equal to the $1,000 profit that we'd like to make every day. So now we have our inequality. 6P minus 265 is greater than or equal to the $1,000 profit that we'd like to make. Since we now have an inequality that we can solve, what's your first step? Remember that when you're solving an inequality, just like when you're solving an equation, you're trying to isolate the variable or get the variable by itself. So what you should think to yourself is, what's happening to that variable and how can I use inverse operations or opposites to get that variable by itself? When I look at this, I notice that P is being multiplied by 6, but we're also subtracting 265. So what do you think the first step would be? I hope you said to add 265. Since subtracting 265 is what's happening here, we need to use the inverse operation, which is to add 265 to both sides of that inequality. Now, negative 265 plus 265 gives me 0. I'm left with 6P here. And then we have our greater than or equal to sign. And then 1,000 plus 265 is 1,265. Okay, so now that we have this inequality, what's our final step in order to isolate that variable? Well, P is being multiplied by 6. What's the inverse or opposite of multiplying by 6? Right, dividing by 6. So we're going to divide both sides by 6. Now, that does get 6 divided by 6 does leave me with P. Keep in mind that sometimes when you have an inequality, you have to reverse that inequality symbol around. Does dividing by 6 mean I need to reverse my inequality? No, we only reverse the inequality symbol when we're multiplying or dividing by a negative number. So 1,265 divided by 6 leaves me with 210 and 83 hundredths. So P is greater than or equal to 210 and 83 hundredths. Awesome job solving that inequality, but now we have to interpret that solution. What does that mean about our problem? How many people do we actually need in order to profit at least $1,000? Well, we need at least 210 and 83 hundredths people, but we can't have 83 hundredths of a person. So at this point, we have to figure out, what does that round to? Well, we're going to need to round up to at least 211 people to ride the roller coaster. When you think about the reasoning behind that and why it makes sense that we would need to round up to 211 people rather than rounding down to 210 people, think about that. So I hope that that reasoning makes sense to you, that if we were to round down to 210 people, because we're missing this 83 hundredths, we wouldn't make enough money. We wouldn't have at least $1,000. So we do have to round up to 211 people to make a profit of at least $1,000. Okay, let's keep going. So now that we've warmed up, we've looked at a problem, we're going to do that same thing with another problem. So let me grab that. Here's our second problem. A youth summer camp has budgeted $2,000 for the campers to attend the carnival. The cost for each camper is $17.95, which includes general admission to the carnival and 2 meals. The youth summer camp must also pay $250 for the chaperones to attend the carnival and $350 for transportation to and from the carnival. What is the biggest number of campers who can attend the carnival if the camp must stay within its budget? Okay, let's use the same strategy that we used for our first problem. We want to read through this and we want to identify the key information. I'm going to highlight it here. You can jot it down on your paper. So I'll give you a second to think about and jot down that key information while I clean the board up and get ready for our next problem. Okay, hopefully you've had enough time to read back through this again, write down that key information. So let's talk through it a little bit. How much is budgeted for the camp? Yep, $2,000. They have budgeted $2,000 for the campers to attend the camp. Great. How much does it cost each camper to attend the camp? $17.95 for each camper. Okay. How much in total does it cost for transportation and chaperones? Well, it costs $250 for the chaperones. It costs $350 for transportation. So just like we did in our previous problem where we added those costs together, if it cost $250 for the chaperones and $350 for transportation, that's a total of $600 that they're needing to pay for those things. Okay. So if the camp has budgeted $2,000, let's start with that number. Since we can't exceed, which can't go over the $2,000, do we need a less than or equal to or a greater than or equal to symbol here? I'll let you think about that one. I hope you said we need a less than or equal to. We can't spend more than that $2,000. So whatever inequality we come up with, that expression needs to be less than or equal to the $2,000. So let's start with less than or equal to 2,000. We can't go over that $2,000 budget. Okay? So right now, that's all that we have for our inequality. We need to come up with the other side there. So what does our variable represent in this problem? Remember that a variable is just a placeholder for an unknown value, and typically we use a letter for that. So what is our variable going to represent, and what is the unknown quantity that we don't know here? Well, we need to know the number of campers who can attend. So let's use P to represent the number of campers who can attend. I'll write that here. P is going to be the number of campers who can attend. Okay, so now that we've defined our variable, let's finish out the inequality. We know that it's going to cost $600 total for chaperones and transportation, and it's also going to cost $17.95 per camper. So our inequality is going to be, it's not a great place, $17.95 for every camper, plus the $600 that we have to pay for transportation and chaperones. And that has to be less than or equal to the $2,000 that has been budgeted. Great. Now that we have our inequality, we're ready to solve. Okay, what would be the first step here? Keep in mind what we did on our first inequality, really similar to solving equations. You're trying to isolate that variable. You're trying to get it by itself. Currently, that P is being multiplied by $17.95, and we're also adding 600 to that. So what's the first step that you're going to have to do in order to isolate that variable? Right, you're going to have to subtract 600 from both sides. Subtract 600 here, subtract 600 here. Now on this side, 600 take away 600 leaves me with 0. So I'm left with the $17.95 times P. Remember that P is our variable. It's representing the number of campers who can attend. That has to be less than or equal to 2,000 minus 600, which is 1,400. All right, so what's your last step to solve this? Good, we're going to divide by $17.95. Now, $17.95 divided by $17.95 is 1. Just leaves me with P. How about this inequality symbol? Is it going to be reversed? Nope, it's not. We didn't multiply or divide by a negative number. We keep that inequality symbol the same. Now we've got 1,400 divided by $17.95. So when you do that division, you get 77 and 99/100. Good work. I'm going to pause for just a couple seconds in case you need to jot any of that down. So now that we have this as our solution to this inequality, we have to interpret it and we have to figure out what it means in the context of this problem. So we're running into the same issue here where this is saying that we need 77 and 99/100 campers to attend. Well, you can't have 99/100 of a camper. So in this case, just like in the last case, we're forced to figure out whether we're going to round down to 77 campers that can attend with our $2,000 budget, or whether we're going to round up to 78 campers who can attend with our $2,000 budget. I'm going to pause for a second while you think about what makes the most sense here in context of the problem. so I hope that after you've thought about this one, you came to the conclusion that we're actually going to round down to 77 campers. If we were to round up to 78 campers, which it seems logical to do, if we round up to a full 78 campers, we're going to exceed that $2,000 budget. Now, how could you figure that out if you weren't sure whether you should round down to 77 campers or whether you should round up to 78 campers? Keep in mind that you can always take those numbers and you can substitute them back in place of your variable, and you can see whether that number that you get satisfies the inequality. So if we take 77, which we've decided is our answer, 77 campers can attend. If you take that 77 and you substitute it for P in your inequality, that number will be less than or equal to 2,000. However, if you were to round this up to 78 and then substitute 78 in place of P, saying that 78 campers could attend, that number is no longer going to be less than or equal to 2,000, which means that we've exceeded our $2,000 budget, which is not okay. So if you're ever in a situation where you're not sure whether you should round down or round up, remember that you can always take those numbers, try them out, substitute them in place of your variable, and see if your inequality is still true. Okay? All right, so far today we've practiced using inequalities to solve problems. I hope that you're remembering that inequalities and equations are very similar to one another when you're solving them. They just have a little difference in that when you're solving an inequality, if you multiply or divide by a negative number, you do have to reverse that inequality around. Also keep in mind from our notes that we took earlier that an equation does show equality and it does have an equal sign, whereas an inequality is not showing equality and it uses the less than, greater than, less than or equal to, or greater than or equal to symbols. Okay, so now that we've done two problems here, you're going to have an opportunity after the video is over to practice some problems on your own. I did go ahead and write down the independent practice problem for you. So I'll put that on the board, give you a chance to read over it and clean up the board, and then we'll go ahead and talk about the important information from this independent practice problem. All right, so let's look at the problem that is your independent practice for today. The carnival owner pays the owner of an exotic animal exhibit $650 for the entire time the exhibit is displayed. The owner of the exhibit has no other expenses except for a daily insurance cost. If the owner of the animal exhibit wants to make more than $500 in profits for the 5.5 days, what is the greatest daily insurance rate he can afford to pay? Just like last time with our other two problems, it's a good strategy to go ahead and go through and highlight or write down the important information. So as we read through this, we know that the carnival owner is going to have to pay $650. Highlighter's running out a little bit. Pay $650 for the entire time that the exhibit is displayed. And I have to pay $650. Now it also tells me that the owner doesn't have any other expenses except for a daily insurance cost. Okay? The owner of the animal exhibit wants to make more than $500. More than $500 is important here. And we want to know what is the greatest daily insurance rate he can afford to pay. Just like we had to do with our second problem, please keep in mind that you're going to need to pick and define a variable here. Our unknown quantity is this greatest daily insurance rate. We don't know what it is. So you're going to want to pick a variable and use that variable to represent the greatest daily insurance rate that he can pay. Also, the other important part of this is keep in mind that part of your inequality is going to need to include this more than $500. In the past two examples that we looked at, we needed to make at least $1,000, which means $1,000 or more. We needed to spend no more than $2,000, so $2,000 or less. But in this case, this person doesn't want to make $500. He wants to make more than $500. So your inequality symbol is not going to include the or greater than in this case. Okay? So if you need to go back to example 1 or example 2, you have those to look back to help you out with your independent practice. Keep in mind our strategy of defining a variable, figuring out what inequality symbol you're going to use, creating your inequality, and then solving from there. All right. Boys and girls, I enjoyed doing some mathematics with you today. Thank you for inviting me into your home. I look forward to seeing you in our next lesson in Tennessee's At Home Learning Series. Bye.